Okay, good morning. So today is 9/7, multiple transformations. This pretty much means you're going to be doing a couple of different transformations in one group. Okay, so the first thing is I'm going to take a look at this rotational symmetry and see what happens with this. Okay. Now, what they want us to do is they want us to, this transformations map the isosceles trapezoid exactly onto itself. Okay, so that means it has to fit perfectly into the diagram, whatever we do to it. Okay, now sometimes having a tool helps. So here's my tool. Okay, and I can see if I can map it perfectly. So first thing I want us to do is see if we can do. We're going to mark ones that work. So we're going to counterclockwise rotation 90 degrees. So counterclockwise means we're going this way. I got a point of rotation in there. So we're going to rotate it 90 degrees. And it does not map onto itself. It's got pieces left over. That one doesn't work. Okay, what about clockwise 180 degrees? So clockwise 180 degrees. So it's this way. And we're going to get around here 180 degrees. We'll bring us to this point here. Line the circles up, and it's not going to map perfectly on that side either because it's got spaces left over. So no. See now. Let's go back to what about across line M? So the section says across line M. Okay. So across line M is this line here is line M, so we're going to follow this way. Does it map perfectly onto itself? No, it does not. Say, what about across line N then? So if I fold it half this way, it will work. And that way it works perfectly, so we're going to mark that one. So think on the shape. Okay. Some work more better than others. Okay. For example, if I use a rectangle, or a square, I should say, square does some great mapping, okay? It rotates 90 degrees, perfectly fine. Rotates 180 degrees, perfectly fine. Okay. It will map across diagonal and be perfectly fine. So depending on the shape you get, so it rotates across the diagonal, maps onto itself. Across the horizontal, versus the vertical line, maps onto itself perfectly. Okay, and if it maps across the horizontal, what about the vertical or the horizontal? Okay, that maps onto it perfectly also. So the squares do everything. They rotate, they map, they do a pretty good job. So squares can do it all, but sometimes triangles can't. So you just get to depend on what this kind of shape you're working with. Okay, your job is to find out which ones work. Okay, so next page. Now what they want to do here is, first off, we want to know on these two shapes, are they congruent? Okay? And they want you to recognize how this how this works, how it goes from A to B or from C to D. Okay? Well, this is a rotation. So these are congruent figures, yes. And then this rotates 90 degrees counterclockwise. This goes this way. Okay, to get up there. So this is 90 degrees counterclockwise. So we got to go down and find that down here and mark that right there. 90 degrees counterclockwise. Okay? Alright, this figure's up here. They are congruent. So therefore they will map each other somehow. Okay? If they're not congruent, go automatically down to the bottom and say none of these because they got to be the same shape. Alright? So 2 across, 3 up, 2 across, 3 up. They map perfectly. Okay? And this is a reflection across the y-axis. So we're going to reflect this across the y-axis, which is right down here. Okay? So it's a matter of you finding which one works and match it. Now this last one here, what we have to do, we want us to look at this and figure out how this is done. Now, this also helps to have a little figure. And so all you do is take a piece of paper and cut it up and make it look like this. And then use it to help figure this out. So we're going from A to B again. So yes, these figures are congruent. But now it's going to take 2 sets. So how do I get from here over to here? So I can do one of two things. I can translate this down and then reflect it. Reflect it looks like this. So that would work. Or I can reflect it first. Okay. Sorry, hold on to it. Reflect it first, and then translate it down. So I can make this shape work. It's not going to be rotation, because rotation would turn this the wrong way here and make it the wrong way. Okay, if I turn it 180 degrees, it goes 90, goes 180, so it's upside down for 180 rotation. Okay, so it's not a rotation. It can't be a straight slide, because it'd be backwards. So there's got to be a reflection in there somewhere. Okay, so what we have here is I have a translate unit down 5 units, so I just take it down 5 units to here. Then I reflect it, and that works out great. So this one works out perfectly, and sometimes I have two, because I can reflect this over the y-axis first, and then translate it down 5 units. So this one has 2. Sometimes I don't have any. You just got to figure out what goes on. Okay, so it's a matter of you seeing how the translations are happening, and then you figure out how to get it in the right spot. They may have 1, they might have 2, they might have all 3, they might have none. So you just got to figure which one happens. Okay, and if they're not congruent, they definitely don't work at all. Okay, all right. So go have a good time. We'll be done with this one.